Yeah. Order is, what is the order? What is the degree? Now tell
Order
me
is
what is.
2
Mhm.
and degree is not defined.
Is it so? Degree is not defined. Why?
Uh,
Degree means, can you recall there was a concept of degree of the polynomial? There was a concept like if we are having the polynomial px is equals to 5x plus 3. Here the highest power of the variable is called the degree. Can you recall it? And here the degree of this polynomial is 1. Degree is 1. If I'll write a polynomial, let's say qx is equals to 6x square plus 3x plus 5. Here the highest power of the variable is 2 and hence the degree is 2. Are you able to recall these concepts?
yes, ma'am.
So this doesn't look like a polynomial.
It does.
It does. Okay. So what is the degree? The highest power of this one is,
1.
so degree, can we say the degree is 1?
Yes.
Yes, we can say that. So first thing first, order, you said it correctly. Order is 2, degree is 1 over here. Okay.
Okay.
What you thought first? Tell me why you said that degree. We cannot say what will be the degree.
Because I considered the dy by dx whole square over.
Okay, this one you considered.
Yes, ma'am.
Okay. So now is it clear that degree will be 1 over here?
Yes, ma'am.
Okay. Let me take few more examples. Just a moment. Okay. So basically, when you will get confused, these are the scenarios. Suppose we are having, suppose we are having d cube y dx cube plus 2 d2y dx2 whole square minus dy dx plus y is equals to 0. Here we will be able to define the degree because it looks like a polynomial. If you will, you can write it as y triple dash plus 2y double dash whole square minus y dash plus y is equals to 0. Can we write it like this, Murtaza? Can we?
Yes, ma'am. We can.
Yes, we can write it like this, and here we will be able to say what will be the degree since we are able to write it in the form of the polynomial, right? This one can be, we are able to write it in the form of polynomial. Now what is polynomial? Polynomial, now only I have given the example that x square, like x cube plus x square plus x plus 5, something like that, or maybe x cube plus 5 only, or maybe x to the power 7 plus x to the power 8 plus 2 only. So these are few example of polynomial where the definition of the polynomial was if the exponent of the variable is a whole number, that's a polynomial. Any algebraic expression where the exponent of variable, if that's a whole number, that's a polynomial. Okay, it exponent of the variable. Suppose I am writing root x plus 5, this is not a polynomial. Okay, because here exponent is 1 by 2, which is not a whole number. Suppose I am writing root 2x plus 5. This is a polynomial because exponent of the variable has to be a whole number. That was the definition of the polynomial in your previous classes, you must have seen. Now here the differential equation, here the definition clearly says that if we can write it in the form of the polynomial, can you see we will be able to write it in the form of polynomial, our differential equation, y triple dash plus y double dash square minus y dash plus y, right? If we
Yes,
can
ma'am.
write it in this form, it's like we are able to represent it in the form of polynomial, and hence if we will be able to say what will be the degree. Now the another example, let me give you. Suppose we are having dy over dx plus sine of dy dx, or maybe log of dy dx, or maybe e to the power dy by dx. That time we will say that degree we cannot say. If I will write e to the power dy dx, sine of dy dx, okay, log of dy dx, if such terms are there, then we can say that like inside the function dy by dx is there, that time we can say that we cannot define the degree over. Getting the difference?
Yes, ma'am.
Okay, so let's do few questions. Find the order and degree if defined of each of the following. The first one is dy dx minus cos x is equals to 0. Let me write all of them. Then we are coming to the order and degree part. Next one is xy d2y dx2 plus x dy dx whole square minus y dy dx is equals to 0. Next one is y double dash y triple dash plus y square plus e to the power y dash is equals to 0. Okay. Now tell me, first one, what is the order, what is the degree? Yes, Murtaza.
Order is 1.
And degree?
Degree also should be 1.
Exactly, the degree is 1. Okay, degree means the power. Okay, the power is 1 over here. Power of this dy dx is 1 over here. Now here, what is the order?
Order is 2 degrees 1.
Order means like we are having differential equation of order 1. When you are having y, and if you are differentiating one time, you will be getting y dash. That means this became differential equation of order 1 now. This became differential equation of order 1. Differential equation of order 1. When again we will differentiate it, this y dash will become y double dash. Now this became differential equation of order 2. Order 2, which we also write as a d2y dx2. Okay. Now again, if you will differentiate it, it will become y triple dash. Yes or no?
Yes, ma'am.
Yes or no, Murtaza?
Yes, ma'am.
Are you getting it?
Yes, ma'am.
Are you there?
Hello.
Can you hear me?
Hello.
Yes, Murtaza, can you hear me? I cannot hear you. I can see you are unmuted, but I'm
Hello.
not able to.
Hello. Hello, ma'am. Hello.
Can you hear me, Murtaza?
Yes, ma'am.
I cannot hear you. Can you write it in the chat box? Anything? Are you able to hear me? Yes, ma'am. That means you can hear me, but I can. Okay. Now can you tell? Now can you say anything?
Yes, ma'am. Hello.
Yeah. Now I can hear you. Okay. Let's continue without this one. So yeah, are you understanding that order means why is there when we are differentiating one side one time it became y dash, which is just becoming order 1 dy by dx, we call it order 1. Any differential equation where we are having, for example, we are having dy by dx plus sin x is equals to 2. This is differential equation of order 1. Why? Because dy by dx is there. Okay, one time derivative is there, that's called order 1. Now two time derivative will be there,
Order 2.
maximum. Suppose dy by dx is also there. Suppose 2 is also there, is equals to 0 is there. Now this became differential equation of order 2. We also call it order 2 differential equation. Why? Because the maximum time derivative over here is 2 times. That is d2y dx2. Okay. Now differential equation of order 3 will look like this. d3y dx3. After that, dy dx, dx2, dy2 can be there, cannot be there, doesn't matter. If 3 times derivative you can see over here, and then after that any other function is there, it's completely fine. We will be saying this is the differential equation of order 3. We call it order 3 differential equation, which looks like this also, d3y dx3 plus d2y, let's say 5 d2y dx2 plus y is equals to 0. Okay, this is also differential equation of order 3. That why? Because maximum 3 times derivative we can see over here, and that will only define the order. Getting it, Murtaza?
Yes, ma'am.
Okay, so how many times derivative is there, that will give you the order of the differential equation. Order 2 differential equation, order 3 differential equation, order 1 like differential equation. These are the order of the differential equation. Now let's get back to our example. The question xy d2y dx2 dy dx whole square is there. Again dy dx is there. Fine. Now can you tell me now what is the order of this differential equation? Yes, Murtaza, maximum number of times we have done the derivative over here, that is
2.
order is
2.
2. Okay, maximum 2 time derivative we can see over here. Order is 2. Getting it?
Yes, ma'am.
Okay, and what is the degree?
Degree is 1.
Degree. Okay, this one's degree we have to check, and that is 1 over here. Next one, order and degree of this differential equation.
Order is 3.
And degree?
Degree is 1.
Degree is 1. Now only I was telling you this type of scenario is not
Oh,
acceptable.
so not possible.
Okay, e to the power dy dx, log of dy dx, any trigonometric function like sine of dy dx. These are the scenario where we will say it's not a polynomial function. Okay, and we won't be able to say what will be the degree over here. So order we can say the highest like maximum 3 time derivative, it is we can see over here. So order 3 differential equation is there, but degree we cannot, we will not be able to say. Degree is not defined over here. Getting it?
Yes, ma'am.
Let's do few more questions. Determine again the order and degree. Okay, number 1, what is the order, what is the degree for the first one?
First is 4. Order is 4.
Order is 4. And degree?
Not possible.
Yeah, what you said?
Not possible.
Not possible. Obviously, it's not a polynomial function. We won't be able to take it as a polynomial function because of this. And hence, degree we are not able to define the degree. Let's do the next one. What is the order? What is the degree over here?
Uh, Order is 1. Degree is also 1.
Exactly. Let's take the next questions. Let me write all of them so that quickly we can cover it. Yeah, let's do. Third one. It's a differential equation. What is the order? What is the degree? Instead of x, y can be there, s can be there, anything can be there as a variable. That's completely okay. Okay. The way you were treating x1, similarly, you have to say what is the order over here, what is the degree over here.
Order is 2, degree is 1.
Degree?
1.
Exactly. Let's do the next one.
Order
Yes,
is uh, order is 2 and degree is not possible.
exactly. Order is 2 and degree we cannot say what is the degree. Not defined. Next one.
Order is 2, degree is 1.
Exactly. Order 2 differential equation it is, and degree, the highest power of that is 1. Next one.
Um, Order is 3, degree is 2.
Degree?
2.
Exactly. Order and degree?
Uh, Order is 3, degree is 1.
Exactly. Order and degree?
Order 1, degree 1.
Perfect. Okay. Understood?
Yes, ma'am.
Okay, two more are there. Order and degree?
Order 2, degree 1.
Order?
2, degree 1.
Exactly. Next one.
Order is 2 and degree is 1.
Degree is?
1.
Exactly. Let's continue. Now we will be seeing how to find the general solution, how to find the particular solution of the given differential equation. So suppose we are having a differential equation. Let's say we are having Just a moment. Let me take one question. Okay, suppose the question is like this. Verify that the function y is equals to e to the power minus 3x is a solution of the differential equation d2y dx2 plus dy dx minus 6y is equals to 0. We have to check whether the given y is equals to e to the power minus 3x. Is it a solution for the given differential equation? Yes or no? We have to verify that. What can be done over here, Murtaza?
Um,
Yeah, what can be done over here? See, we
first
have to,
we
yeah,
first we differentiate it. We get minus 3x into e power 3 minus 3x.
exactly. And then,
And then we do the second order.
yeah, second order derivative we will be finding. And then we will substitute all the values on the left hand side of the given differential equation. And we will check, are we going to get the right hand side, that is 0? If we are going to get, it's a solution. If we are not going to get, it's not a solution. Simple. Okay, so as you said, let's do it together. Then I'll give you a few more questions which you will be able to do by yourself. So let's do it. We are having y is equals to e to the power minus 3x. We will be finding the derivative first time, which will be y dash or dy dx is equals to
3x minus 3x.
minus 3x
Just minus 3 into e power minus 3x.
minus 3x into e to the power minus 3x. Is it so?
Uh,
Whenever we have to find the derivative like this, we know the formula for e to the power x. We know the formula of derivative of e to the dx of e to the power x. Formula is given in the book, that is just e to the power x only. But here we are having minus 3x as a power. So how we will use the formula? Yes, we will use the same formula by using the chain rule. What the chain rule says, that use the formula as it is. Ddx of e to the power minus 3x will be e to the power minus 3x only. But since the power you are going to treat as a, like this power we have treated as a just x. Okay, here in the formula just x was there. This power over here we are treating as a x only. So we have to differentiate the power one more time. Or you can say
okay.
this power is different from the formula and we have used the formula directly. So now we are supposed to now we are supposed to do the derivative of the power separately. So multiplied with derivative of the power separately, that is minus 3x. Why we are doing so? Because this power is not exactly our formula, and this one y is equals to minus, like minus e to the power minus 3x, it looks like the formula but not exactly. So we can use the formula, but one extra step we are supposed to perform over here, that is the chain rule. This is the extra term which we have to derivate, like find the derivative by doing the multiplication like a chain. Getting it?
Yes, ma'am.
Okay, and from here only we will be getting Murtaza. From here only we will be getting, which you are saying no, -3 will be there in front. Yeah, -3 from where we got it? We got it by doing the derivative of -3x. What will be the derivative of -3x? Tell me. Tell me what will be the derivative of -3x, Murtaza?
-3.
Just -3. That's why you must have seen everyone write it directly over here. That is dy dx is equals to -3 e to the power -3x. Because this part we are doing in our mind.
Yes,
e to the power -3x will be as it is according to the formula. Plus -3x looks like extra term. Okay. So that derivative again we have to perform. And from there we are getting -3, which we can write in front. Any confusion?
No, ma'am.
Now one more time we will do the derivative by using the same concept. Can you tell me what are we going to get? Can you tell me what are we going to get?
Yes, ma'am.
Tell me.
1 minute.
Are you saying anything?
I'm not getting it, ma'am.
Okay. Okay, you are not getting it.
Yes, ma'am.
Okay, let me show you. Here, -3 is a constant term. We will write it like that. And again, we will do the derivative of e to the power -3. E to the power -3x derivative will be, the formula says whenever you are having d dx of e to the power x, the result is just e to the power x. So if we will use the formula, we are getting the derivative of this one will be as it is. Whatever is there, it will remain as it is. But hey, this one doesn't look like the formula exactly. There is a change. Okay, there is, can you see the power is different? Again I would repeat the same thing, the power is different, so we have to do the derivative of that again by doing the multiplication. So -3, the constant term, I have copy pasted. Keep it aside. Constant term is there, just keep it aside and then focus on the function. If you will find the derivative of the function, again you have to repeat the same process. That is, you will completely focus on doing the derivative of e to the power -3x. E to the power -3x derivative will be e to the power -3x only. But this -3x is different from the formula. So that derivative again we have to do by using the chain rule. Getting it?
Yes, ma'am.
Now d2y dx2, the simplified form will be -3. This one I am copy pasting over here. E to the power -3x. I am writing like this. Derivative of -3x will be, Murtaza?
3. -3.
-3. Okay. This -3 and the front one -3. Since all are in just multiplication with each other. See, 5 into 4 into 3 can be written as 5 into 3 into 4. It can also be written as 3 into 4 into 5. Does it matter, Murtaza?
No, ma'am.
No. So we can write this 3 -3 in front and we can multiply both the number. We can write this one and the last number together and we can multiply it directly even without writing it. We can multiply them and it will come out as a 3 into 3, 9. That too, tell me, positive 9 or negative 9?
Positive.
positive 9. 9 e to the power minus 3x we are getting as a d2y dx2. So the step which we are getting 9 e to the power minus 3x, you will see that everyone write this step directly. Directly from here we can write this step. Whenever we are having, see, whenever we are having dy dx is equals to, let's say, e to the power 2x, e to the power 2x we are having, or maybe 5 e to the power 2x we are having. So directly we can write it, d2y dx2 will be 5 will remain as it is. E to the power 2x derivative will be e to the power 2x only, but extra 2 will come when we will do the derivative of 2x. Okay, and that extra 2 will get multiplied with 5. So directly 5 into 2, 10 we can write. Am I making sense to you?
Yes, ma'am.
Now let me give you one scenario. Tell me what will be the result. Suppose dy dx we are having as sine 3x. Okay, and yeah, 5 sine 3x. Tell me what will be the double derivative. It is like that only. Think about it and tell me.
Okay, ma'am.
Yes, Murtaza, what are we going to have? Derivative of sine x will be,
Minus cos x.
is it minus cos x?
One. Sorry, it's cos x.
Just cos x?
Yes,
Derivative
ma'am.
of sine x is just cos x. So
Yes,
here
ma'am.
we can use the formula that it will be cos 3x. But something is different. It was not exactly like the formula. Can you see?
Yes,
What is
ma'am.
the change? What extra step we have to perform over here? Can you see the angle is not like the formula? We have used the formula of sine x,
Yes, ma'am.
but it is not x. So this 3x again we have to do
What do you call chain rule?
derivative. And that will be
3, just 3.
just 3. This 5 and 3 can get multiplied together. So 15 cos 3x we will be having. Are you getting it, Murtaza?
Yes, ma'am.
Is it crystal clear to you?
Yes, ma'am. It's clear.
Suppose, suppose we are having y is equals to 1 by 5 log 5x. Tell me what will be the derivative. Yes, Murtaza, what will be the derivative?
Uh,
Think about it and let me know. It is exactly like the previous two examples. Derivative of log x is derivative of log x is
1 by x.
1 by x. Now I am not going to say what will be the answer. You are going to tell me what will be the answer. Tell me. Can we use the formula of log x over here?
Ma'am, 1 minute. Yes, ma'am, we can.
Yes. Okay. What will be the result?
1/5x into log 5.
1/5x into,
Log 5.
is it log 5? log x का तो फॉर्मूला है ही हमारे पास. log x का तो फॉर्मूला है ही जो बोलता है कि डेरिवेटिव करने पे 1/x होता है. तो यहाँ पे log है x के प्लेस पे 5x है, कोई बात नहीं. इस 5x को x की तरह ट्रीट कर देते हैं. क्या करते हैं? इस 5x को x की तरह ट्रीट कर देते हैं. तो क्या होगा? log x का फॉर्मूला बोलता है डेरिवेटिव के बाद 1/x आता है, तो यहाँ पे आएगा 1/5x. बट हमने 5x को x की तरह ट्रीट कर दिया. तो अब again we have to do the derivative of this 5x. Am I making sense to you?
Yes, ma'am. Okay, so into 5.
Into 5, and this 1/5 which is there in front, it will remain as it is. Now you will find that 5 gone. That's completely okay. Now you will realize that answer is just 1/5x. That will be the perfect correct answer. Getting it?
Yes, ma'am.
Any confusion?
No.
क्या नहीं समझ में आ रहा है? सबसे पहले देखेंगे कि कौन सा फॉर्मूला हमारे पास है जो ऐसा दिखता है. वही फॉर्मूला एज इट इज अप्लाई कर देंगे. बट अप्लाई करने के बाद काम खत्म नहीं हो गया हमारा. हमारा काम अभी खत्म नहीं हुआ है, क्योंकि हमने यहाँ पे एंगल कुछ और था, एंगल 3x था, उसको x जैसे ट्रीट कर रखा है. यहाँ 5x था, उसको x जैसे ट्रीट किया है हमने. यहाँ पे एक्सपोनेंट e टू दी पावर x वाला फॉर्मूला 2x के लिए अप्लाई कर दिया. तो यहाँ 2x को अभी फिर से डिफरेंशिएट करना बाकी है. आ रहा है समझ में?
Yes, ma'am.
तभी तभी जो आंसर आता है, जो आज तक तुमने देखा है आंसर, कि जब भी हमारे पास होता है e टू द पावर 2x और उसको जब डेरिवेटिव करते हैं तो डायरेक्टली लिखते हैं 2e टू द पावर 2x. क्यों ये 2 लिखते हैं? क्योंकि 2x को फिर से डेरिवेटिव किए हैं तो 2 आया है, उसी 2 को फ्रंट पे रखते हैं. Am I making sense?
Yes, ma'am.
Let's continue. So d2 by dx2 we got, dy dx we are having in hand. Now we have to check whether it's a solution or not. So we will substitute everything over here. Let's do the substitution on the left hand side and let's check, are we getting 0 or not? Are we going to get 0 or not? Not here. Here. Our left hand side is d2y dx2
Which is
dy dx minus 6y. Do the calculation, Murtaza, and check it. Are we getting 0 or not? Do it. Substitute d2y dx2 which we have found so far.
okay, ma'am.
Okay, d2y dx2, see, we have found 9 e to the power minus 3x. dy dx we have found minus 3 e to the power minus 3x. Everything we will substitute over here and then we will check, are we going to get 0 or not? And yeah, y also we will substitute.
And what's the formula? The solution?
See, this is the question.
Yes, ma'am, we get 0.
Are you getting 0?
Yes, ma'am.
Okay. So here we have got 9 e to the power minus 3x. Here we have got dy dx, we have got minus 3 to the power minus 3x. And this one we have got 6y, that means 6
Into
e to the power minus 3x. Yeah. Minus 3 minus 6 minus 9 plus 9 gone 0. Yeah. Let's do few more questions. Few more, not all the question from the exercise, because as I said, you need to practice all the question from the NCRT. So the first one is y is equals to e to the power x plus 1. Okay. And we have to check over here whether it's a solution of the differential equation. See, this is a differential equation. That
yes,
is
ma'am.
y double dash minus y dash is equals to 0. Now from y we will be finding y double dash, we will be finding y dash, and we will substitute over here to check whether we are going to get 0 or not. Do it. Do it in a fresh manner, Murtaza. Okay, after the class I need the snap of all the part where you are doing the solution. Okay.
Okay, ma'am.
Anywhere you are getting stuck, let me know. I will help you.
Okay. Ma'am, e to the power x plus 1 is equal to, oh, no, no, no. Yeah. Uh, okay.
Yes, what are you getting?
Yes, ma'am, it's 0.
Yes, it's 0. Let's check it. Y dash will be, tell me, y dash will be?
Y dash will be e to the power x plus 0.
Hmm. And y double dash will be?
E to the power x.
Yeah, it will be 0. Let's do the next one. Like this, you need to do all the questions from here. Quickly, let's do one by one, all of them. Check it.
Yes, ma'am, it's 0.
It's 0. Okay.
Yes.
Y dash is equals to
2x plus 2.
Yeah. When we will substitute over here or directly here we are going to get. Obviously it's 0. From here only we can see. Let's do the next one. Y is equals to cos x plus c. Y dash plus sin x is equals to 0. We have to check it.
Yes, ma'am, it's 0.
Yes.
Y dash is minus sin x. So y dash plus sin x is minus sin x plus sin x, which is 0.
Exactly. Let's do the next one. This type of question will come in the exam, the actual exam, and you will feel like how you got such a difficult, tricky question. But believe me, this type of question only comes in the exam. If you will like sure about NCRT, the whole NCRT, then definitely like more than 70%, believe me, 80% marks you will be getting. Few questions are there which can be like quite tricky, but most of the questions are like this only, Murtaza. You just need to understand the concept. Getting it?
Okay, ma'am. Yes, ma'am.
Next one, if we are having y is equals to under root 1 plus x square. And here it's given that y dash is equals to xy by 1 plus x square. Just a minute. Do it.
Okay, ma'am, I got it.
Yeah.
Dy by dx is equal to 1 into 2x by 2 into 1 plus x square.
See, do we have, yeah, first tell me what you have written.
Uh, 1 into 2x.
1 into 2x,
Yes, ma'am.
then
Divided by 2 root 1 plus x square.
2 root 1 plus x square. Can you tell me how you got it?
Chain rule.
Yeah. How you got it, Murtaza?
By chain rule, ma'am.
Yeah, by chain rule. Under root 1 plus x square, how it came in the denominator? This under root 1 plus x square, which is
Yes, ma'am.
perfect. I just want to know how exactly it came in the denominator, this one.
Uh, it was already in the denominator. No, no, no.
It was in the numerator. How it just gone in the denominator, which is perfect. How it gone, just that I want to know. Yes, Murtaza.
Yes, ma'am.
You have done the derivative of that. 1 plus x square, you have done the derivative, right?
Yes, ma'am. But I don't know how.
From where you have written this answer.
I remember this, ma'am.
Okay, you remember
I
this?
remember this.
This
Yes, ma'am.
exactly came from here. Do the derivative of y is equals to root x.
Uh,
What are we going to have?
we get x raised to 1 by 2.
X to the power 1 by 2 is there.
Yes, ma'am.
That will be, we will be able to use the
1
formula
divided by 1 divided by 2 root x.
n x to the power n minus 1 is the formula. So formula will be n x to the power n minus 1 will be 1 by 2 minus 1 will be
1 divided by 2 root x.
yeah 1 divided. I'm just asking 1 by 2 minus 1 will be what?
1 by 2.
1 by 2 minus 1 is what?
Oh, minus 1 by 2.
Minus 1 by 2, and hence it came from here only 1 by 2 x to the power 1 by 2. This minus 1 by 2 gone in the denominator became plus 1 by 2, and from there only we got 1 by 2 root x. Yes or no?
Yes, ma'am.
Okay. Yeah. If you remember it directly, yes, we can write it directly only. But we must understand, if different scenario will be there, suppose x cube will be there, x to the power 4 will be there. So what? So what? We will be doing it like this only. Under root something is there, we are going to treat it like under root x. So it will be 1 by 2 root x. But something is different inside the root. It is not just x. It is not just x.
square.
So yes, you said it correctly. By chain rule, we have to do the derivative of this 1 plus x square. 1 plus x square, we are doing the derivative. 1 is becoming 0 and x square is becoming 2x. Yes or no?
Yes, ma'am.
Yes, your answer is perfect. 2 gone. dy dx is equals to x by under root 1 plus x square we are having. But we have to prove something else. So are you able to prove it? Like it's given that y dash is equals to this, but we have got y dash is equals to something different. Do you can you tell me how can we get whatever is given
I
as a
couldn't prove
differential?
it. I couldn't prove it.
Yeah.
I could not prove it.
Rationalization concept we can apply here. Whatever is there in the denominator, we can multiply in the numerator also, in the denominator also. Why we are doing so? Because in the denominator, in the proof part, in the denominator only 1 plus x square is there. Yes or no?
Yes, ma'am.
And we are having under root 1 plus x square. So how we will get rid of this root sign? Get rid means how we will remove this root sign? By doing the multiplication of the same term. Okay, if you are having in the denominator root 5, but in the proof part there is just 5. That means you can multiply one more root 5. Getting it?
Yes, ma'am.
Okay, so that's what we can do, but it's a fraction. So we are bound to do the same term multiplication in the numerator also, which will give us x under root 1 plus x square by just 1 plus x square. Because under root same term, it's just square root vanished and we are getting this one as a dy dx. But still we are not getting the proof. But now are you
1
able
plus
to identify?
1
We will
plus
get it.
x
Why we can
root 1 plus x square is y.
Yeah, 1 plus x
So
square is
x
square
y
root
by
is y.
1 plus x.
So we can write it and hence we are done. The given differential equation solution is given over here. Okay.
Okay, ma'am.
Any confusion, Murtaza?
No.
Let's do the next one. Y is equals to ax and xy dash is equals to y. It is given that x is not equals to 0, of course. X is not 0 over here. Do it. Just a second. Do it. Yes, Murtaza, are you able to do it?
Do we is a constant?
Yeah. A is a constant. Okay. A is just a constant.
So while finding the derivative, we should bring a outside. And just find x's derivative.
Exactly. The way you are going to treat 2, 3, 4, any number, same way we will be treating this a.
So it will be just a.
Y is equals to just
A.
a. Y is equals to just a. Now let's simplify the left hand side part, because if we are not getting directly, then maybe we will simplify the left hand side and then we will get the right hand side. Or sometimes we have to do left hand side simplified form, right hand side simplified form, and then we have to check both the simplified form are same on it. So x y dash we are having x, let's keep it as it is. Y dash is only a. X into a we are getting, or ax we are getting. Is it same as a y? Yes or no?
Yes, ma'am.
It is. Okay. So which is same as a y, we can say left hand side is equals to right hand side, hence it is a solution. Let's do the next one. Let's check it, Murtaza.
X cos x plus sin x derivative.
Yeah.
X cos x plus sin x.
First function derivative of second one plus second function derivative of first one. Perfect. Let's substitute. I say to you, when you are not getting it directly, then maybe left hand side you have to solve and you will be getting the right hand side. And sometime maybe we have to solve both side and then we will be able to say, yeah, both side we are getting same. This is y dash. So x y dash is x cos x plus sin x. Right, Murtaza?
Yes, ma'am.
Okay. So left hand side is basically, this is we are having as a left hand side, or we can also apply the distributive property, right? We can write it as a x square cos x plus x sin x, right?
Yes, ma'am.
Just a moment. Let's do the right hand side as well. That is y plus y is x sin x plus x under root x square minus y square. X square is okay, but y square is x sin x. That means minus x square sin square x. Right, Murtaza?
Yes, ma'am.
Let's continue. We need to do the simplification over here, and we need to use the knowledge of trigonometry, the formulas and everything, maybe identity, maybe any other formula. Let's check it. So x sin s is perfect, plus x is outside, that is perfect. Here we are having x square minus x square sin square x. If we will take x square common inside the root only, then we will be having 1 minus sin square x. Yes or no?
Yes, ma'am.
1 minus sin square x is what? 1 minus sin square is what?
It's
1 minus sin square is what, Murtaza?
it's cos square x.
It is cos square x. And x square is there. All in under root. Are you getting what are we going to get outside of the root sign? X square cos square x will be
X cos x.
x cos x, x cos x. One x is already sitting over here. X sin x. This x into x will be x square, right?
Yes, ma'am.
Are we having the same left hand side? Are we? Check it.
Yes, ma'am, we have.
So left hand side and right hand side came out as the same, and hence we are done. Any confusion, Murtaza?
No, ma'am.
Sometimes, like whenever a exercise starts, basic question, level 1 question, level 1 question, level 1 question, where you will start like just after solving like few steps you will be getting the answer. Those are level 1 question. Then there comes a level 2 question where you have to simplify the left hand side and you are getting the right hand side. And then there comes a level 3 question where like in our curriculum in NCERT, in CBSE, it's not given as a level 1, level 2, level 3. But in IGCSE, IB, they give as a level 1 question, level 2 question. Like first level 1 question, 20 questions are there. Then level 2 question, 30 questions are there. Then level 3 question, 2 questions are there. They give it like this. Here also the same sequence is maintained. But when we will just move forward, we have to realize that. So this was level 3 question. Can you see it?
Yes.
Is it difficult?
No.
It's not. It's not difficult. You just need to understand that sometime we have to solve the left hand side and even the right hand side also. Then only we will be able to check both sides we are getting same or not. Let's do the next one. ऐसे ही
Ma'am,
बैठ के
this
आराम आराम से एक एक क्वेश्चन बनाते हैं, तब जाके कॉन्फिडेंस आता है कि ये चैप्टर तो क्लियर है मेरा.
yes,
आ
ma'am.
रहा है समझ में?
Yes, ma'am. This question was there in the last exam.
Can you tell me?
This question was there in the last exam. The same question.
Just a second, I'm not getting. Just a moment. Okay. Let me. Yes, Murtaza, tell me what you said.
This question was there in the last exam.
This question was there in the last exam.
Yes,
Is it
ma'am.
difficult, Murtaza?
No.
And this question, believe me, it will carry 4 marks, at least 4 marks, at least. More than that can be the case, but at least 3 to 4 marks it will easily carry.
Okay, ma'am.
If you will practice everything from NCRT, can you see my screen?
Yes, ma'am.
Okay, wait. I think it got paused or not. Yeah. Okay, if you will practice like this, each and every question, then you will be confident. You will be able to understand. Okay, this way we are not getting, maybe that way. Okay, that way also we are not getting, maybe the right hand side also we need to simplify. Everything will click if you will practice. Maths is a subject only. Okay. The
Okay.
next is xy is equals to log y. I have seen a student when they start understanding the concept, they feel like I'm not going to solve the easier question. But believe me, you have to solve the easier one and then progress. You have to make the progress and then you have to take the tricky questions as well. But at first, only just after understanding this question, if you will not solve everything, you will get stuck. Here
Okay.
the proof is y dash is equals to y square by 1 minus xy. Here xy is not equals to 1. Solve it.